Welcome to our channel. We're thrilled to have you here. Today, we're diving into the fascinating world of chemistry to uncover some of the most bizarre and intriguing chemical elements you didn't know existed. These elements are not just part of our textbooks. They are part of our everyday lives in ways you might not expect. Think of the periodic table as a cast of characters, each with its own unique and sometimes downright strange personality. Some are shy and elusive, while others are bold and explosive. We're talking about the unsung heroes, the mysterious hermits that hide in the shadows, and the explosive rock stars of the elemental world. These elements can light up the sky and bring a concert of reactions to life. Get your lab coats ready, because things are about to get elemental. We're going to explore the science that makes our world so wonderfully unpredictable. We're going to peel back the layers of the ordinary and peer into the extraordinary. Nature has hidden gems that are waiting to be discovered. From the super rare to the super reactive, these elements have stories that will captivate your imagination. Prepare to have your mind expanded and your curiosity ignited. It's science time. Let's embark on this incredible journey together. Let's kick things off with francium, element number 87, one of the most elusive and fascinating elements on the periodic table. The rarest of the alkali metals, francium is incredibly reactive, making it a subject of great interest and curiosity among scientists. It is even more reactive than its alkali cousins like sodium and potassium, which are already known for their vigorous reactions. Discovered by the brilliant French scientist Marguerite Perret in 1939, francium was a groundbreaking find in the world of chemistry. Francium is formed through the decay of actinium-227, a process that highlights its fleeting existence. Its longest-lived isotope, francium-223, has a half-life of only about 22 minutes, making it one of the shortest-lived elements. This extreme rarity and short half-life make it incredibly difficult to study, posing a significant challenge for researchers. Imagine trying to understand something that disappears almost as soon as you create it. It's like trying to catch a ghost in a bottle. If you could gather enough francium and drop it into water, the reaction would be nothing short of spectacular. The reaction would be explosively violent, a dramatic display of chemical energy. Francium is the most electropositive of all known elements, meaning it is extremely eager to shed its outermost electron. When francium meets water, it would instantly rip apart the water molecules, causing a chain reaction. This violent interaction would result in the water molecules being torn apart, releasing an enormous amount of heat. The heat released would be so intense that it would ignite the hydrogen gas produced in the reaction. The hydrogen gas produced would ignite explosively, creating a fiery spectacle. So, what can we do with francium? Given its extreme rarity and instability, its practical applications are virtually non-existent. Its practical applications are virtually zero due to its rarity and instability, making it more of a scientific curiosity than a useful material. It's mainly of interest for research, helping scientists understand atomic behavior and the properties of highly unstable elements. By studying francium, researchers can gain insights into the behavior of atoms and the forces that govern their interactions. Francium, the ultimate elemental drama queen, making a brief explosive appearance and then vanishing in a puff of scientific intrigue. Its fleeting existence and dramatic reactions make it a fascinating subject of study, even if it remains largely impractical for everyday use. Next up, astatine, element number 85, is practically a ghost. This elusive element is so rare and fleeting that it almost seems like a figment of our imagination. It's a halogen, like fluorine and iodine, but incredibly radioactive. Its radioactivity makes it both fascinating and dangerous to study. Its most stable isotope, astatine-210, has a half-life of only about 8 hours. This means it decays rapidly, making it difficult to observe and analyze. Astatine was first synthesized in 1940 by bombarding bismuth with alpha particles. This groundbreaking discovery opened up new avenues in the field of nuclear chemistry. Less than a gram exists naturally on Earth at any given time. This extreme scarcity adds to its ghostly reputation. Studying astatine is challenging due to its intense radioactivity and scarcity. Researchers must take extreme precautions to handle it safely. Most of what we know is inferred from its position on the periodic table. Its properties are predicted based on its neighbors, iodine and polonium. Despite its challenges, astatine holds potential for medical applications, particularly in cancer treatment. Its ability to emit alpha particles makes it a candidate for targeted therapies. Isotopes like astatine-211 are researched for targeted alpha particle therapy. This could revolutionize how we treat certain types of cancer. Astatine, the unstable element with a potentially stable future in medicine, its ghostly presence might just become a beacon of hope in the medical field. Let's talk about bromine, element number 35. One of only 2 elements liquid at room temperature. Bromine is a dense, reddish-brown liquid that evaporates into a highly irritating vapor. Discovered in the 1820s, bromine's name comes from the Greek word for stench. It's a strong oxidizing agent, reactive with many elements. Bromine is toxic, requiring extreme caution when handled. Despite its hazards, bromine is used in flame retardants, water purification, and pharmaceuticals. Bromine, the element that proves liquids don't always have to be cool and refreshing. Let's shift gears to xenon, element number 54, a noble gas known for its unreactive nature. Discovered in 1898, xenon was once thought to be completely inert. In 1962, Neil Bartlett created the first xenon compound, shattering the belief of its complete inertness. Xenon is used in lighting, producing a brilliant white light close to natural daylight. It's found in movie projectors, searchlights, and high-intensity car headlights. Beyond lighting, xenon is used as a propellant in ion thrusters for spacecraft. It also has medical uses, acting as an anesthetic and being researched for neuroprotective properties. Xenon, the noble gas that's full of bright surprises. Now let's venture into the realm of radioactivity with polonium, element number 84. Discovered by Marie and Pierre Curie, polonium is incredibly rare and highly radioactive. Polonium-210 is a pure alpha emitter, making it extremely toxic if ingested or inhaled. Despite its hazards, polonium-210 has niche industrial applications, like anti-static devices. It was also used as a lightweight heat source in space probes. Unfortunately, polonium-210 gained notoriety in a high-profile poisoning case. Polonium, a tiny titan of alpha radiation, for better or for worse. Let's talk about radon, element number 86, a noble gas that's highly radioactive. Radon is colorless, odorless, and tasteless, making it a sneaky health hazard. It's formed from the decay of uranium and thorium, seeping into homes from the ground. Inhaling radon can lead to lung cancer, making it the second leading cause after smoking. Testing for radon is crucial, as it's the only way to detect elevated levels. Radon mitigation involves sealing cracks and installing ventilation systems. Radon, the dense, invisible, radioactive noble gas that serves as a crucial reminder of hidden dangers. Now for something unique, technetium, element number 43, the first artificially produced element. Discovered in 1937, technetium is absent on Earth except for minute traces. Technetium-99m is widely used in medical imaging as a radioactive tracer. It has a short half-life, making it ideal for diagnostic procedures. Technetium-99m helps doctors see inside the body, aiding in the diagnosis of various conditions. Technetium, the element we built that now helps us see inside ourselves. Let's get heavy with osmium, element number 76, the densest naturally occurring element. Discovered in 1803, osmium is incredibly dense and hard, with a high melting point. It's used in specialized applications like fountain pen tips and phonograph needles. Osmium tetroxide, despite its toxicity, is used in microscopy and organic synthesis. Osmium proving that sometimes being dense is a good thing, at least in the elemental world. Let's delve into thallium, element number 81, known for its toxicity and surprising modern uses. Thallium salts were historically used in rat poisons, earning it the nickname the poisoner's poison. Despite its dangers, thallium has applications in electronics and medical imaging. Thallium-201 is used in cardiac stress tests to assess blood flow to the heart. Thallium, the element that's both a villain in crime novels and a hero in the hospital and tech lab. For our final bizarre element, let's talk about einsteinium, element number 99, discovered in a nuclear explosion. Found in the debris of the Ivy Mike hydrogen bomb test, einsteinium is highly radioactive. It's a synthetic element, produced in nuclear reactors and used in scientific research. Einsteinium, an element forged in fire, honoring a mind that illuminated the world. And there you have it, folks. A whirlwind tour through some of the most bizarre, fascinating, and downright strange chemical elements. From the explosively reactive francium to the man-made marvel of technetium, each element tells a unique story. Science is an adventure, and the periodic table is one of its most exciting maps. Understanding these elements helps us understand the world on a deeper level. Thanks for watching. If you enjoyed learning about these bizarre chemical elements, make sure to like, subscribe, and hit the bell icon for more fascinating science content. Until next time, stay curious, keep asking questions, and never stop exploring the amazing world of science.